Hello everyone, welcome back to Math 1314, more on math. Today we're going to talk about Chapter 4, Section 3. Section 3 deals with polynomial division, remainder, and the factor theorems. So there are actually four things that are our objectives today. First, we're going to look at the polynomial division. There are two parts here. There's long division is used to determine if a polynomial p of x, I said p sub 1 of x, is a factor of a larger polynomial. Alright, so that's what long division is for. Now the second one is a shortcut to that called synthetic division. Synthetic division, it looks weird when you first start it, but it's a lot faster. But limitation only works when the denominator polynomial is of the form x plus or minus some number. So it has to be, the denominator, the number on the bottom, has to be a linear binomial. Linear binomial. In other words, it can't have any exponents, can't have any coefficients, and it can only have two terms. Then we're going to look at the remainder theorem. The remainder theorem is used to find values of C such that values of this function, and hopefully they can't be 0. So the remainder theorem, when we do a division, whatever is left is your remainder, and that's the value of C that we'll look for. And the fourth is the factor theorem. This is used to determine if our linear binomial x plus or minus c is a factor of our polynomial. Alright, so let's look at this. Those are our objectives for this section. Generally, we know that, let's say we had a function, f of x equals x squared plus 7x plus 12. We figured out in the past how to factor those in the last chapter. We can either factor complete the square or the quadratic formula. But let's look and see if we factor this. So what makes up x squared? X times x. Remember, the value that goes here is always the middle value. So x times x equals x squared, so we're using that term. Then we look at the second term. There's a second sign. It's a plus. What that means is both of these numbers here have to have the same signs. They have to have plus. Then we look at the last term, 12. What times what equals 12? When you add them, you get 7. 4 times 3. All right. Then once you factor this equation, what we do is we set them equal to 0. So x is equal to -4 and x is equal to -3. These are our solutions, our x-intercepts. All right, so if we plug these values back inside here, f of -4, if we plug that back into the equation, and work it out, -4 squared is positive 16. Positive times negative is negative. 7 times 4 is 28. 16 plus 12 is 28. 28 minus 28, it equals 0. That's how come we say our solutions these are our solutions. They're also the zeros, because if we plug them back in the equation, it'll be 0. And because it equals 0, that's also why they are the x-intercepts. Same thing happens if we plug -3 back into the equation, it'll equal 0. Okay, so if we know the factors, if we know these factors, we can find the zeros. Now, we can also go backwards. If I give you the zeros, then you could find the factors, and you could also find the equation it came from. We just work backwards. So let's look here. So let's go what we had last time. We ended up with f of x equals x squared plus 7x plus 12. We knew that the factors, we determined the factors were x plus 4, x plus 3, and our zeros became x equals -4 and x equals -3. Actually, what we did is we set them equal to 0, and we got our solutions. So we start off with the function and ended up with our zeros. Function to zeros. Now let's work backwards. If I give you zeros of an equation, you can tell me the factors and the function. So look at this. So if I give you zeros, let's say the zeros are x equals -4 and -3. Let's work backwards. So if there's zeros, that means we know that x equals -4 and x equals -3. Let's make them 0. So if we add 4 to both sides, we get x plus 4 equals 0. And if we add 3 to both sides, then we get x plus 3 equals 0. That's why there's zeros, because they equal 0. Okay, since those are our two factors that equal 0, we can take them and put them together. Oops, x minus 4. That's really 4. Now, since it's this way, let's multiply them together. X times x, x squared. Positive times positive is positive. X times 3 is 3x. Positive times positive is positive. 4 times x is 4x. Positive times positive is positive. 4 times 3 is 12. Combine like terms. Whenever you get rid of parentheses, always combine like terms. X squared, 3 plus 4 is 7x, plus 12 equals 0. And so there is our function that gave us those two solutions. So it's just working backwards. But that was pretty easy. What if I gave you a polynomial that looked like this? So far, we've only learned one method of solving these type of polynomials. Can we use grouping? If we group the first two and the second two, they don't have anything in common. So we can't use grouping. So we look at another process here. Let's see this. This is called the rational approach to it. We know that from up above that if you divide a polynomial p of x by a smaller polynomial, we'll call that p1 of x, then you will end up with a quotient polynomial. We'll call that q of x, and a remainder polynomial. We'll call that r of x. So okay, we'll show you what that means. So what we're going to do, so if I give you a polynomial, yeah, it's easy if I give you the solutions. I mean the factors. That's easy. But to get from here to here takes a lot of work. There's a lot of steps involved. So let's look what this means. We're going to start using fractions to solve these things. So like I said, if you have a polynomial and you divide it by a smaller polynomial. By smaller, I mean the degree of the numerator, p of x, is greater than the degree of the bottom polynomial. So the degree of p of x is greater than the degree of p1 of x. So looking at these two, we know that the bigger equations on top has a higher exponent. So when you do division of polynomials, you'll end up with a quotient, and sometimes you'll end up with a remainder. And this is the important part. If the remainder equals 0, then, if the remainder is 0, then p1 of x, the denominator, is a factor of p of x. And that's a very important piece of information. So if the remainder is 0 after we do division, then we know that this is a factor of that. Alright, so as I said here now, the degree of the numerator has to be bigger than the bottom. Now, also, the degree of the quotient part is always less than the degree of the main polynomial. So the degree of this one has to be less than that one. That's a must. And the degree of the remainder is also less than the degree of the bottom, or it's 0. So the degree of the remainder, the degree of the remainder is less than the degree of the denominator, or it's 0. Okay, now remember, degree equals the largest exponent in a polynomial. All right, so that's very, very important. So let's look at an example here. Let's look at long division. You've actually done long division before. If you think about that, it's 12 divided by 3. That's the p of x, that's the p1 of x. It equals what? 12 divided by 3 is 4, with no remainder. How about 11 over 3? 3 goes in 11 3 times, with 2 left over, so that's our remainder. This is p of x. This is p1 of x. This is q of x. And this is the remainder, r of x. We do the same thing with polynomials. Let's use the example with the one we used earlier. X squared plus 7x plus 12. X plus 4. Notice the degree of the numerator is 2. The degree of the denominator is 1. So that's what this says. The degree of the degree of the top has to be greater than the degree of the bottom. And that's what we got here. That's the first step. Now, how do we perform this? Because remember this old method here? We also learned to do it this way. How many times 3 go into 12? 4 times. Once we put the 4 there, what do? 4 times 3 is 12. Subtract it, and there's your remainder. So there's your quotient, and there's your remainder. The bottom number goes into the top number. 3 goes into 11 3 times. 3 times 3 is 9. Subtract them. You're left with 2. Since this number is smaller than that, we can't go any further, so we have a remainder of 2. And it's written this way. 2 over 3. Or this is the remainder. So whatever's on top is your quotient, and whatever is left on the bottom is your remainder over the denominator. So in this one, then we take the bottom number and put the big polynomial in there. Now, only look at the leading terms. What times x gives you x squared? X. X times x is x squared. Once you find a value, multiply it to each term. Of the denominator. So that's the denominator. I found the term. So x goes into x squared. X times x is x squared. So now we reverse. X times x is x squared. X times 4 is 4x. Change the sign, because you're subtracting, so you have to change the signs. That's what we did up here. It was 4 times 3 is 12, but we have to change the sign to subtract them. So I have to change both of these signs, and now I add them. X squared and x squared. The first terms have to disappear. That's the whole objective. 7 minus 4 is 3x, and bring down everything else. Repeat the process. Look at the leading terms. What times x gives me 3x, or positive 3x? So it's a positive 3. So 3 times x is 3x. 3 times 4 is 12. Change the signs and add. First term cancels. Yeah, there's your remainder. Since your remainder is 0, all we have left is our quotient. Right, so there's our answers. If we take this polynomial divided by x plus 4, we get x plus 3. Now, reviewing back what we did in the old days, remember, so 3 goes into 12 4 times. 43 is 12, so change signs. So we decided that that's our answer. How do we check it? If we take the bottom number and multiply it to the top, so 12 equals 3 times 4. 12 equals 12. So to check it, multiply the quotient by the denominator. And it should equal the numerator. Here's the numerator, denominator equals quotient. N equals D times Q. That is how you check it. So in our example, x squared plus 7x plus 12 over x plus 4, we said equals x plus 3. There, whatever's on top is your solution. So let's check it. Take this denominator and multiply it to the other side. X plus 4, x plus 3. X times x is x squared plus 3x plus 4x plus 12, x squared plus 7x plus 12. Since these equal, then that's our solution. But here's the cool part. These are the factors of that. So that's just another way we can factor them, by using division. Yeah, it's a lot of work to doing on this one. But what about the one I gave you earlier? There's x cubed plus 2x squared minus 5x minus 6. Find the factors there. I mean, I gave them to you earlier. I gave them to you earlier. They were x plus 3, x plus 1, x minus 2. To find the factors, start with x plus 1 then divide it, see if it works. Then do x minus 1, see if it works. And then x plus 2, x minus 2, and keep on going. Because we know we have 3 answers. So let's try. So let's try the first one. Take this one, x cubed plus 2x squared minus 5x minus 6. Let's divide it by x plus 1. That's the first. Then we'll try x minus 1. If this one doesn't work, we are looking for solutions with remainder of 0. So x plus 1. X cubed plus 2x squared minus 5x minus 6. Remember, always start looking at the leading terms. So what times x gives you x cubed? So just missing 2 more x's. So take this, multiply both of those. So x times x, x squared times x is x cubed. X squared times 1 is 1x squared. Subtract. So we change these signs. Now add them. The first term cancels. That's a good sign. 2 minus 1 is 1, so we just have x squared. Bring everything else down. Minus 5x minus 6. Now, let's start again. What times x gives you x squared? A positive x. X times x is x squared. X times 1 is 1x. Change the signs and add. X squared minus x squared cancels. Negative 5x minus 1x is negative 6x. Bring down what you have left. And repeat the process. Look at leading terms. What times x gives you negative 6x? There's x times x. So it needs a negative 6. So negative 6 times x is negative 6x. Negative 6 times 1 is negative 6. Change the signs and add. Negative 6x plus 6x is cancelled. Negative 6, we have the remainder of 0. So, x plus 1 is a factor of x cubed plus 2x squared minus 5x minus 6. Remember, we need 3 factors because it's a third order equation. It's a degree 3. So this is only one of the 3. So this equals x squared plus x minus 6. That answer goes there. Okay, that's the first part. So we know this one works. Now we try x minus 1. But here's the more important thing. You notice our answer we have left? This is all we have to look at now. Since the remainder is 0, we only have to look at this. X cubed plus 2x squared minus 5x minus 6 over x plus 1 equals x squared plus x minus 6. We know this is one of the factors. So now, since there's no remainder, let's factor this one out. Since it's a quadratic equation, let's go ahead and use one of our methods. X squared is x times x. The negative means they're opposite signs. One's positive, one's negative. The bigger number gets a plus. So, what times what equals 6? When you subtract them, you get 1. 3 and 2. 3 times 2 is 6. 3 minus 2 is 1. So, we've just found our 3 factors. Squared minus 5x minus 6. It factors out to being x plus 1, x plus 3, x minus 2. So once we find the factors, we know the zeros, those are the x-intercepts, those are zeros. Alright, so that's the process we're going to look at now. Alright, so that's using long division. So we start off with x plus 1. That doesn't work, we try x minus 1. If the remainder isn't 0, we keep on going with the next one. That's what the remainder theorem is all about. So, if we have a value c, and we plug it in, if we plug it inside the function, if we get a remainder, if we get a number, that's the remainder. So f of c is the remainder of our polynomial divided by x minus c. Okay, now what does all that mean? Remember, remember these I just put up here earlier? So there's your remainder. If I plug in the value inside the equation, I will get 2 left. It works the same way with polynomials. So for example, x squared minus 7x minus 12. Well, now let's do the same one we just had. We know the factors are x plus 4, x plus 3. The zeros are negative 4 and negative 3. Now what does all this stuff have to do together? Let's check. To check if negative 4 and negative 3 are zeros of the polynomial, plug them into the equation, into the polynomial, and check to see if the solution equals 0, which we did. We did that earlier. Those are the zeros. And that's what that's what I said earlier. The polynomial, if I had x plus, let's say, c, this I have here, I can check to see if this equation is a factor. In other words, now I take the bottom, set it equal to 0, solve for x. X equals negative c. If I plug that negative c inside here, and it equals 0, then x plus c is a factor. If not, then x plus c is not a factor. X cubed plus 2x squared minus 5x minus 6. Yeah, we did the long way this way. And we got solutions. But we could have saved our time by saying, is this going to be is x plus 1 an actual factor of this? Take this, set it equal to 0, and solve it. We get negative 1, obviously, but that's opposite sign. If we take this negative 1 and plug it in the original equation, we plug it in here. Let's see what happens. If it equals 0, then we know that this is a factor, and we can go on. If it's not 0, don't waste your time. Negative 1 cubed is negative 1. So it's negative, negatives, negative. 1 times 1 times 1 is 1. Negative 1 squared is positive 1. Negative times negative is positive. Negative 1 plus 2 plus 5 minus 6. 2 plus 5 is 7. Negative 1, negative 6 is negative 7. So now we determined that since this is 0, we know that x plus 1 is a factor. And we can go ahead and do the division and see what we have left remaining of it. Whatever's left, that's all we have to do. Divide it by x minus 3. I'm sorry, same equation divided by x minus 3. We're going to do it both ways. Let's do it long division. And we're going to check the value. Let's do the check the value first. So we have our equation divided by x minus 3. Take the x minus 3 and solve it. So we get x equals 3. Plug this into the numerator. So anywhere you see an x, put a positive 3. Squared minus 5 times 3 minus x. 3 squared. 3 times 3 is 9 times 3 is 27. 3 squared is 9. 2 times 9. Positive times negative is negative. 5 times 3 is 15. Minus 6. 27. 2 times 9 is 18. So 27 plus 18 is 45. Negative 15, negative 6 is negative 21. 45 minus 21 is 24. It's not equal to 0. So x minus 3 is not a factor. And here's another. So remember, so if we plugged in that, we got 24 as, and it's not equal to 0. But we will have a remainder of, this is the cool part. So let's do long division. X minus 3 x cubed plus 2x squared minus 5x minus 6. So all the leading terms. So what times x is x cubed? That's x squared. X squared times x is x cubed. X squared times negative 3 is negative 3x squared. Change the signs and add. Those cancel. 2 plus 3 is 5. Bring down everything else. Again, what times x gives you 5x squared? Since 5 is positive, it's a positive 5x. I need 2 x's, I only have 1, so it's 5x times x. 5x times x is 5x squared. 5x times negative 3. Positive times negative is negative. 5 times 3 is 15. X. Change the signs and add. Those cancel. Positive 15 minus 5 is positive 10x. Bring down the 6. X, what times x gives me 10x? It's a positive, so it gives me positive 10. Positive 10 times x is positive 10x. 10 times negative 3 is negative 30. Change the signs and add. Positive 30 minus 6 is 24. There's your remainder. You notice it's the same value as we got there. So If we do it this way, take the bottom, set it equals 0, plug it in there, we can find the remainder as a remainder of 24, which is exactly the same as that one. Okay, so that's looking at both ways. So we know that x minus 3 is not a factor. Clearly, it won't always be that straightforward. So if I gave you this and asked you to factor it, right now you start off with x plus 1. Does that work? No. X minus 1. Does that work? No. Let's see. Or you plug in negative 1. And if the remainder is 0, then it's a factor. So if I plug in negative 1 inside there, and work it out. It's negative 1. Since it's 0, it's easier if I had this. I solved equals 0, plugged it in there, I got 0. So since the remainder is 0, I know that x plus 1 is a factor of it. X minus 1, not so lucky. So I solve x plus 1, I get 1. I plug 1 inside the equation. So we get 1 plus 2 minus 5 minus 6. 3 minus 11 is 8. So it's not a solution. Then I go for x plus 2, x minus 2. See if that works. But the problem with this method here, since it equals 0, we know it's a factor. I still have to do long division. Have to do long division to find the other factors. I mean, you could try this all the way through, but the answers won't always be solid numbers. It may be fractions. So that's why we do this first and see if that works. Because that's a lot of work, that's why this process, synthetic division, was invented. Synthetic division only uses the coefficients. Of the numerator. And the 0 of the denominator. So let's look at this example. 2x cubed plus 7. Actually, before we do this one, let's look at the one we just did, since we know what's supposed to happen. So remember, the coefficients of the numerator, and take the 0. So the 0 of the bottom is -1. I'll use this value and the coefficients. Synthetic division, the dividing thing looks upside down now. So I have 1, 2, -5, -6. Only the coefficients. So this is the x squared, x cubed I mean. This one's the x squared, this one's the x, and this one's the constant. This is important because if one of these are missing, then you have to put a 0 there. You have to allocate each column from the highest exponent down to the constant. All right. In synthetic division, first step, bring down the first term. That's the first step. Now, multiply this times this and put it there. That's it. Multiply equals that. Now add straight down. 2 minus 1 is 1. Repeat. Multiply -1 times 1 equals -1. Add straight down. -5 plus -1 is -6. Repeat the process. -1 times -6 equals +6, and add, we get 0. There's your remainder. So, since the remainder is 0, we know that this -1 is an answer, which means that x plus 1 is a factor. These tell us the remaining polynomial. This is our constant. This is our x term. And this is our x squared term. We work backwards. Or another way you could do it is, since x cubed is divided by x, the answer is going to be x squared. So start with x squared and work your way down. All right, let's do another synthetic division. That's what I was going to put earlier. This polynomial is divided by that binomial. So we're using synthetic division. So inside here, okay, remember we have, here's x cubed, x squared, x, and a constant. You have to go all the way down. So the coefficient of this one is 2. The coefficient is +7. There's no x, and there's a -5. Now, what goes over here is always the opposite, but it's the 0. Remember, synthetic division, you cannot have a coefficient in front of the x or an exponent. It has to be x plus or minus some value. Now we do synthetic division. The first term comes down. Multiply. Negative 3 times 2 equals negative 6. Add. 7 minus 6 is 1. Negative 3 times 1 is negative 3. Add. 0 minus 3 is minus 3. Negative 3 times negative, so negative is positive. 3 times 3 is 9. 9 minus 5 is 4. That's the remainder. So since your leading original term was x cubed, this one starts off with x squared, because I divided by 1x. Then it's a positive x minus 3 plus the remainder of 4. That's how you write the remainder. The remainder over the denominator. Okay, this equation, I could have also given it to you this way. 2x cubed plus 7x divided by that. So 2x cubed plus 7x squared minus 5. I can ask you, find f of negative 3. If I give it to you this way, I already put the 0 in there. Then just put negative 3, 2, this is x cubed, x squared, x constant. So positive 7, there's no x's, minus 5. And then we repeat the process. Bring on the first term, multiply, you get negative 6, add straight down. Well, since there's nothing here, 2 plus 0 is 2. Multiply. 7 minus 6 is 1. Multiply. 0 minus 3 is minus 3. Multiply. Negative 5 plus 9 is 4. So if given x plus or minus c, here's a polynomial, then find the 0 of x plus or minus c. If given polynomial and asked to find f of c, then just use that value. You don't have to change anything. So if I give you a fraction, or something divided, then find the 0 of the dividing part, the divisor. Just change the sign. If I give you, find the specific value, then just plug that value in there. For example, f of x equals 2x to the 5th minus 3x to the 4th plus x cubed minus 2x squared plus x minus 8. Find f of 10. Alright, so since this is f of 10, I have 10 there. This is the highest exponent, x to the 5th, x to the 4th, x to the 3rd, x squared, x, and constant. So the coefficient of x to the 5th is positive 2, negative 3, 1, negative 2, 1, negative 8. Bring the first one down. Now, 10 times 2 is 20. 20 minus 3 is 17. 10 times 17 is 170. 70 plus 1 is 171. Ooh, wow. 10 times 171 is 1710. 1710 minus 2 is 1708. So this times this number gives us 17080. Plus 1 is 17081. Multiply this times this. It's 170810. Whenever you multiply by 10, just put a 0 behind the number. 17 times 10, 170. 171 times 10 is 1710. So now 170,810 minus 8 is 170,802. So there's your remainder. You would write the answer this equation. This is your polynomial. 2x to the 5th minus 3x to the 4th plus x cubed minus 2x squared plus x minus 8 over, since I'm finding f of 10, this is my 0, the bottom would be f minus 10. Because that's my 0, x equals 10. So I subtract 10 from both sides to get a 0. So that's what I have in the bottom. Now the solution would be all these. This is your remainder. So x to the 5th divided by x. So this one would be 2x to the 4th, because I took away 1x to my solution, plus 17x cubed plus 171x squared plus 1708x plus 17081. Since that's positive, it's 170802 over x minus 10. That's how you write the answer. Is 5 a 0 of this function? X to the 4th minus 26x squared plus 25. So how do we figure that out? So all I'm asking is this 5 a 0 of this polynomial? One way I could do it, just plug in 5. 5 to the 4th power, 26 times 5 squared, plus 25. All right, so let me, for simplicity purposes, and so we can go ahead and speed this whole process up, let me use a calculator here. So we have 5 to the 4th. So I have 5 to the 4th equals 625. 5 squared is 25. So 26 times 25 is 650. $625 plus 25 is 650. Minus 650 equals 0. So, yes, 5 is a 0 of g of x. Didn't ask us to find the rest of the remainder polynomial, but once we know this, then we can use synthetic division x to the 4th, x cubed, x squared, x constant. So this is the coefficients 1. There's no x cubes. Negative 26. There's no x's. Bring down the first term. 5 times 1 is 5. 0 plus 5 is 5. 5 times 5 is 25. 25 minus 26 is negative 1. 5 times negative 1 is negative 5. Zero minus 5 is negative 5. 5 times negative 5 is negative 25. The remainder is 0. So this is the next polynomial we have to look at. Since it started off as x to the 4th, we lose 1, so it's 1x cubed plus 5x squared minus 1x minus 5. Repeat the process as we just did. But all this question asked was, is 5 a 0 of g of x? Unfortunately, it is possible. Here's another example. Is I a 0 of g of x, where g of x is x cubed minus 3x squared plus x minus 3? Because it is possible to have imaginary answers. We do it the same way. So we have x cubed, x squared, x, and constant. So this is coefficients 1, negative 3, 1, negative 3. Same process. So bring down the 1. Or 1 plus 0 is 1. Multiply. I times 1 equals I. So, and we add them, so we get negative 3 plus I. This times this. So I times negative 3 is negative 3I. I times I is I squared, which becomes negative 1. And we add 1 minus 3I minus 1. The 1's cancel, so we have minus 3I. I times negative 3I is negative 3I squared. I squared can't change the sign. Negative 3 plus 3 is 0. So I is a factor of g of x. And this is what we have left. So the next time we have to look at is just look at this one. It's going to be x squared plus I minus 3x minus 3I. That's the remaining polynomial. Let's check if negative I is a solution or a factor with this one. So the coefficients of x squared, x, and the constant. So we have 1, I minus 3, minus 3. Multiply. Negative I times 1 is negative I. Add these. So I minus I cancels, so we have negative 3. Negative I times negative 3, negative is positive. 3I. So it's 1. I times 1 is add those. The i's cancel, so we have negative 3. Negative is positive 3I. So it's negative, positive 3I minus 3. So, no. So, now let's put it all together. Let's find factors of p of x, of a polynomial. The theorem says, for a polynomial p of x, if p of c equals 0, if we plug in some value c inside there and equals 0, then we know that x minus c is a factor of the polynomial p of x. So that wraps up everything we just did. So if we have find a value, plug it in there, and it equals 0, then we know that x minus that value. So if p was negative c equals 0, then x plus c is a factor. Remember, it's whatever is inside here is always the opposite sign inside the parenthesis. Alright, so let's look at an example. This one's going to be pretty large. So, f of x equals x cubed minus 3x squared minus 6x plus 8. So we're going to have three factors. Remember, so we can start off by looking at doing division with all of these until we find one, and then once we find one, it'll be a quadratic equation, and we can just, or we can just plug in those values and see if we get a 0. Let's see if x plus 1 is a solution. So I'm going to use synthetic division since it's much faster. So I get x cubed, x squared, x constant. So it's 1, negative 3, negative 6, 8. Where has to factor this one. Bring down the first one. Negative 1 times 1 is negative 1. Negative 3 plus negative 1 is negative 4. Negative 1 times negative 4 is 4. Negative 6 plus 4 is negative 2. Negative 1 times negative 2 is 2. So, that's not a factor. Let's try the next one. 1. Same values. Bring down the first one. 1 times 1 is 1. Negative 3 plus 1 is negative 2. 1 times negative 2 is negative 2. Negative 6 minus 2 is negative 8. 1 times negative 8 is negative 8. So, we know that x minus 1 is our first factor. Since 1 worked, it means x minus 1 is a factor, because it's a remainder of 0. Which means, since it started off with x cubed, that means this one is x squared minus 2x minus 8. Let's see if we can factor this one. X and x squared. So this makes it opposite signs. What times what is 8? When you subtract them, you get 2. The bigger number gets a negative. 4 times 2 is 8. 4 minus 2. Yep. So my solutions, my factors are these. Those are my factors. Zeros are x equals 1, 4, and negative 2. Alright, so good luck in your homework, and that comes up next.